So, um, looking into one particular thing today. Um, so, basically, we have like error messages right now in the compiler, but there's one thing that normal compilers usually do that, I mean, not usually, like always do, that we have not done yet, which is to actually like have all the errors displayed that are found at one go in the compilation. Um, this is something that people just take for granted when they use a compiler. They, like, you build a project and you see like multiple errors, and then you solve those errors and try to like get them eliminated. But the idea that you can have multiple errors showing in one single go in a compilation process is actually something that has to be like handled, because if you think of normal errors, like if you have a program that is throwing an error, usually what happens is that it fails at some point, and because it failed, then the program stops. But if you stop at that point, then you'll only have one error at a time. So, for example, currently, uh, like if I have a program, so I've written this program, and just I deliberately added an error in this. Um, so right now in our compiler, it will here. Where is it? So if you compile this, yeah, so we're getting an error, and I mean, okay, this is like there's only one error here, but like if we, so int I equals, let's say, ace, like, so we can't assign a character to an integer. Oh, actually, even this won't fail because we are not in type handling right now. Can we do? We can remove this. Yeah, this should fail. So these are, now we are having two errors, but it will still only give that error, because right now what we are doing is that the moment we encounter an error, we just throw it and exit from the program. So if you look at the program right now that we have, like we in the parser, so actually we are using a parser. So for throwing errors, we are using a function. Like, I mean, in the parser it's throw parser error, and it's got something else in different places, but basically it's handled at one place, how we're handling the error. But in the end, you can see we have an exit one. So this is the reason why it is only able to print one error at a time. So when the compiler is parsing the program, it will encounter something that it is supposed to get but it didn't get, and it will identify that as an error, and then it will print it and exit. But what we should have in a more sophisticated case is we should expect something. If we don't get it, then we should tell the user that this is the error that we got, and you should have not done this thing. But then we should move on and continue looking at the remaining part of the code, so that if there is something that's wrong anywhere else, you can also identify that and print that also. So this is how it would work in any other case. Like, I think I was looking into some program. So this is a variant program. If we like make the same kind of an error in this C program, save it and compile. What do I have? Campus. I think this is C. Oh, we have this. So wait. Visual Studio installation history. Okay. So this is problem in the environment. I want to delete that. So first I have to open the PowerShell. So this should work. So here it is. Yes, so here we can see we have two errors, and that's like the way it should work. It expected there to be a data type int, and we got k int, so that is the first error, which we are also doing. We are handling that. So okay, I deleted it. So we are also handling this thing, but thing is that we want to be able to handle, like if we were able to show both together, that is a better user experience. Because right now it seems like a small problem, like you can fix this error and compile it again and see the other error, but realistically, like in my program, so like this is also a program, like this is like having so when I make a change, I'll make many changes in many files, and then I'll build the project, and many errors will occur in different places. But if I only print one error at a time, then I would see like one error, I'll have to fix that, and then I'll have to compile it again, and then I'll get another error, and I have to keep compiling it after fixing every error, and I won't know actually how many errors are there and how many times I have to fix it, which is there might be like maybe 30 errors. So it would be like extremely bad. It would be like a frustrating experience, especially not know how many errors there are. That's even worse. Uh, like it could be like there are only 2 errors, but there might be 10 errors, so you don't know until you like compile it every time after fixing every error. So that is not good. But this should be not too hard to solve, because if we look at the way we are doing it, we are handling all errors at one location and we are exiting in this itself. So theoretically, we just have to not do this, and the program will continue. Uh, but it is not so simple, because like because this is an error. Like something is not done as it should be, which means that like once we have encountered something that's wrong, like it might be like, for example, how to explain it, like once you go wrong somewhere, the whole thing might just be unnecessary to keep throwing errors for. um, like if you have some random thing, uh, maybe this is what you have, right? So like this whole thing is like there like many mistakes in this. So there's the wrong data type, then we have a bracket here that doesn't close, this is like a not, and this is also a wrong data type. So this whole sentence has many errors. Not sure like how we should handle this. So a very basic way of handling this could be to just look for like these kinds of characters like semicolons. So in your program you'll have like in C style, these kinds of languages, so we have like braces and semicolons, which are going to tell us like where things are like segregated. These are like different statements, and this is like a block, and this is another block. Uh, and so that gives us a way to identify structure in the code. So if something is wrong in one part, you can know where you can skip until you reach some other part of the code. So like we can skip the whole statement and say like if we encountered an error here, we don't even need to look at this, like because now we don't know if this thing even makes sense, because this first thing didn't make sense. So how do we know like what this thing should be? Like it could be anything after that. So maybe we should just ignore the whole thing. Like obviously in this case, like we have written it in a way that it just looks like it should be maybe like a function prototype, but maybe not. Maybe like this bracket is like something, it was supposed to be like this, and it was a typecast on something, and we were calling some function, and who knows really. I mean, it's outside, so it and it's sending a semicolon, so it looks like a function, but I mean, like, this is a different example, but like it can get complicated maybe. So broadly, the idea I think should be like, maybe we can just keep it simple for now. I don't know, like, maybe there are like more sophisticated ways of doing this, but this would be, I think, a simple way to just look for like these kinds of characters or tokens, um, like the delimiter, and I don't know. I think delimiter is good enough. That probably is like the main thing. But also we'll have to look for like right braces, because ultimately, wait a minute. Other cases where there's no delimiter, yeah. Mm, so I was thinking of these kinds of scenarios. Uh, so if something is like some garbage here, and then you have normal code, so maybe there's an error in this part of the code, but you don't want to skip the entire if block. You would still want to be able to run the parser on these statements inside this. So this is like a kind of thing we would like. So this would apply for even like for loops and while loops, like whenever we have some kind of thing in the parenthesis, um, which I think is not that bad, because we can identify it with something that ends in a right parenthesis, so we know that we need to stop here. um, so I guess that's okay. So we can, if you have an error in this, we just skip until this part is done, and then the block statements begin. So that is one thing that can be done. Maybe we can use go to statements? Yeah, that would be. I mean, it's like a hack, but maybe not a hack, because that would make this very easy. Like wherever we have like, if we go into the parser, parse expression. So we get, where is this? This is the condition, right? So if something gets thrown in this, and ultimately we are passing the block here. So I mean, we still have to kind of go with the flow. So we can't actually use go to statements, because the way we are working is we are using these kinds of things to move through the program. So we are getting tokens, we have to like consume tokens, and that is how we are moving forward. And the only way to do that is to actually call this function to keep moving forward. So whatever is the flow of the parser, that kind of needs to be followed. Okay. Maybe like, so I don't know, like this thing might not even work, like it might, like, because so this is like going to be a major change, because it could break in many places, maybe because this is like a major part of the flow of the front end. But we can try to see what happens. Maybe we can just do like we can just like throw like do an experimental, let's see. So maybe we just remove exit one. Let's try exit one here also. Could not find current token. Okay, this is I think fine, because could not find token means that literally you have reached the end of the file. So you reach at the end of the file in a case where like should not have been at the end of the file, like you expected something, and if you're at the end of the file, like then errors are like there are no more errors to find. So then this is okay. So we just need to remove this. Um, so if we do that, so let's just do it for throw parser error, right? Like there is a throw error function in the lexer, but like I think there are fewer lexer errors. There are errors H. So there are like I guess like around 20 errors in the lexer, and these are most of them are here. So then there's like some in like okay, I don't know if this is even correct, but like right now in our compiler, so when we are converting to LLVM, we are also finding errors there, um, which seems wrong. Like this should be part of like some kind of step before the IR generation. IR generation should not really have errors if it's like if the code has been checked syntactically and semantically, uh, then I guess it should have. Maybe these are like semantic errors. Um, yeah. So, anyways, I mean that's fine. Okay, so this build. So we remove that. Okay. So what should we expect? So right now, where was the error coming from? So if we go parser CPP, parse declare no, not function definition. Oh, A is function definition. Function. So yeah, we are expecting the return type, then function. If it's null, so token type it. If it's not identified, type info map. Yeah, so here if we don't have a type, this will be null and it will throw invalid return type for function definition. So I think we got that error. Do we remove it again? I remove it. Oh, now it's like I built it, so now this is like totally different. Okay. So now we have multiple errors, but it looks like it's literally throwing errors at every place. This is like what we don't want. Okay. Invalid. Oh, this is. Why is it printing? Okay. Same thing is printed twice. Invalid expression. Failed to pass expression. Accepted identifier to primary expression. Invalid. Failed to pass. Okay. Yeah, okay, so I think we can do the skip thing. That I think that is the right way. So what we should do, basically like if we have this kind of a thing, when we reach here, so we are here, then we have got an error, and first of all I think it didn't fail at main, so So something was correct there, I guess. But like if we reach here, so this was the place where we got one error. Uh, so now I think the problem is that this whole thing just doesn't make sense. Uh, so we can explicitly tell the program to like skip everything until this part, and like then we can just go to the remaining block. This is like we'll have to handle this everywhere. This will be manual. Okay. 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 How many functions are there? Parse blocks. Okay, 89, yeah. 94 is source, so that's probably in parser.h. Yeah. Okay, so basically it's 89. So most of the errors are in the parser only, which makes sense. Parser block. So whenever, okay, so if token null, oh, but many places we are doing null or something, then we have to, okay, it's fine. Okay, that is fine because we are checking that in this already, so that's good. Okay, so that's not a problem. Tokens. So for null thing, so wherever token equals null is the thing that's being checked. So that we just don't have to worry about, which is good. So this whole thing, okay, so basically this whole thing is fine. Parse expression, we will get there. Parse if statement, yes, this we can ignore, this we can ignore, and this we need to check. Left parenthesis, if expression, condition, if we don't have this. Okay, this should we, okay, let's check. Okay, for now let's keep it. So like I was thinking that like in some languages like I think Go and in Jonathan Blow's language also J, like you can just have statements without parentheses and all. If for and why, I think they don't need parentheses. We could like change uh, that in this language as well, but at the moment like we have kept it like mandatory. So okay, we can think about that later. Right now we are expecting left parenthesis, which is useful because then that means that we will stop at the right parenthesis. Which is where is it? Here. Oh yeah, because we are using it as the stop token for this whole parsing thing, which actually means that our parser is not so. Is the logic something wrong with the logic? Because clearly, like it's possible to parse expressions without needing to know, like where it will, what is the token that needs to be at the end. So the fact that we need to pass it is kind of suspicious. Something is not good in this logic, but okay, it's fine. Condition, thesis, is kind of condition. Yeah, so yeah, we need to modify many things. Okay, let's just maybe try doing that. Most likely this won't be done in one go. I mean, there are too many errors that have to be handled, but we can try doing it one at a time. Like, like it would be kind of worth it, I guess. And it is like kind of a basic necessity. So for a compiler, I think this we already saw is fine. This is fine. This is fine. Null fine. For this, what we should do is we should define this as define it as null and now I just do this otherwise condition. Okay, so now we have that. So through parser and if we do that, we want to skip until we reach a right parenthesis, and this is okay. Skip until right parenthesis. Okay, even that is, we have to write that logic. So parse page. Okay. parentheses. Let's keep this like this. We don't need this, right? Anyways, okay. Just open it here. So here we'll need to like see. So if you encounter any left parenthesis, uh, then we need to like count that. So start with this. We are skipping. So currently we would be at the place of the error. So we need to get the next token. So we can do that. Next token. What should we do? Or it could just be a while. Token is equal to get this token. If This break, otherwise we just reduce this and then we keep going. So we keep getting the tokens. If we get a left parenthesis, so then we need to get the matching pair for that one. So we have to keep checking that. So we keep consuming tokens and until we reach the right parenthesis. Makes sense. We need to still check. We can check for null what. So we get next token. Maybe just it's okay. Okay. If token is null, since this is going to be only used for errors, so we can I think this. So that's fine. So this will allow us to skip for that. So this is for left parenthesis. Then we need something for braces. We need something, but because of block statements, we should not have something. Okay, maybe this should be checked for sentence. Skip until beginning of so and this can be direct because or I think this should be fine. So deleted and break. Otherwise, we keep getting the tokens. Should be okay. parenthesis. So here we should call that skip until right parenthesis. And once we have done that, we just need to then we can actually use go tools. I guess maybe we need to do that. Let's pass a block. Okay, actually we need to be here. same thing. The while list has a condition and also before I forget, we put the name we call parse tokens. Here we need to have a way to tell if an error was thrown. So let's say we need to maybe store something to found is false, and when we parse so first thing to do should be to or maybe go to analysis. Check this first. Done one. So this is different kind of error. This okay, that's fine. So we can go back to this, this. set down expression. Display return. Okay, return expression. Null. This seems okay. Inception tokens function. So missing denominator at the end of statement. This will happen if the function called if it's organized. I think this should work already. So we won't exit here. It will continue normally. This should be okay. Next to expected elements. Oh, this is defining this. Yeah, just remove this. So this we can remove. It's unnecessary. Oh, No, but this is null. I'm a little bit doubtful about this, but yeah, I guess we can see what happens. logic is pretty convoluted, and I don't skip anything anywhere, so I'm just unsure whether this even will work. But I mean, it looks like it should work. So I guess would be something best. Okay. This part is like already so complicated that I'm not sure even if it's correct, because there's something wrong during parsing. Like it works, but I think it messes up the syntax tree. There's something in the precedence that is not correct. So I mean, but that shouldn't be much of an issue in this, but the point was basically that the logic is really weird for this whole thing. Although it's not that big function. So let's use what is this? Okay, basically should not be limited. Oh, I mean, this, this name is longer than just doing this. Yeah. Anyways, okay. It made sense earlier because earlier I didn't have error codes like macros, so I was just having long strings. So I think using function names looked nicer, but now it doesn't make sense. So maybe I should just replace this because it's basically not helping in any way. What statement. Should have used very place if I want the command. It's done. We can go back in this search. This will cause some complicated errors. I've used two so many times like the default should have been true. See, like, this is not the way I'm using it. I'm mostly using it for throwing an error and just exiting. But yeah, I think this error must be something related to missing delimiter at the end of the statement. Okay. Stops. Okay. I do have stops. Favorite symbol would also be this is another stupid. Maybe I should have used that. But the problem is that the way I'm using this parse sub-expression and what is that? Parse decrease in precedence. So the way right now it is implemented, these are both recursively calling each other, and so it's not so easy to just skip them. At least the way I have written it. It should be possible to obviously write this better, but yeah, right now let's see what to do. Okay. So I'm probably like just tired, so it's possible I'm going to just miss many things now. So it won't be surprising if there are many runtime issues. They'll probably not be builders, but testing this in runtime will be difficult because basically the changes we have made are going to affect the details of the entire flow, because things that would just stop just immediately are not going to stop now. So in a way that shouldn't be bad, because this all surely affect cases where we have errors in the program, and it should not affect a program that is correct. So if a program is correct, all these things that we have made should kind of not affect anything. It should only make a change in cases where there are errors, because earlier you just stop as soon as we encountered one error, but now we need to make sure that if there are errors, then the parser is able to function after the point from which it has skipped an error, and that part we have never tested before. So I mean, if it works for the correct case, then it should work even for that case, but still it will be like it will be new. Insufficient documents function machine. This doesn't look like something. Again, this is unnecessary. No. So, can just choose this. Oh. Hmm. So build succeeded. So we have this one. First, let's just run it. So this should compile without errors. Oh, print oh, actually it's good. Found both errors here. Null data type must parameter and null return type. That's a positive sign. That's nice. Let's see this. Something on that. Let's just check the error just for now. I'll fix the debugging stuff. Maybe I'll do that tomorrow. Boom. Okay. Basically, yeah, because it's an expression, we are not skipping anything. So there are many bugs, I mean, but I'll look into that tomorrow, I think. So probably I have to like debug this. Let's see what happens till then.